Hello, hi everyone. It's good to be here at Node.js Interactive. This is my fourth Node.js Interactive. I missed the last one in Vancouver, but I'm glad I'm here this time around. My name is Irina. I'm an engineer at MongoDB. I work on the GUI interface for our database. I'm based in Berlin, but I'm originally from Vancouver. I was raised here and moved away about 2 years ago. So this is home, and it's nice to be home. And today I'm going to talk to you about HTTP2 and the protocol itself and how it works in Node.js, and a little bit more about the protocol itself and kind of the interesting things about it and the things you can do with it. So why HTTP2? What is it? Let's kind of go to the sources and see what the experts in the field are saying about HTTP2. HTTP2 is a major protocol shift with the potential to accelerate the web. So it's a thing that makes our web a lot faster. That's good to know. HTTP2 will make our applications faster, simpler, and more robust. Again, faster and more robust. This is good to know. We want to make our web fast. And it is a more efficient way to parse, more compact on the wire, and most importantly, they're much less error-prone compared to textual protocols like HTTP1. So today, we're going to explore a protocol that's a lot faster than what we have right now, and what will make our applications a lot more robust and less error-prone. So let's dig in. HTTP2. So in today's agenda, we've got some comparisons between HTTP1, so we get a little bit of the basics. We'll talk a little bit more about some of the specifics. We'll computer a little bit, and we'll talk about what makes it so fast. And finally, we'll talk a little bit about HTTP2 push, which is kind of one of the more interesting things about HTTP2. All right, so let's talk about kind of the differences between HTTP1 and HTTP2 so we get a little bit of the basics down. All right, so the focus of the protocol is on performance, specifically end user perceived latency, network and server resource usage. All right, so let's go back to 1991 when HTTP 1.1 was first introduced. Traffic was a little bit less slower than it is right now. So you can look at the 2010 HTTP2 archive and kind of look at how much data was sent over the wire, and it's a lot less than it is today. And last year, obviously, doubled, tripled from there. So we're getting a lot more traffic over the web. And HTTP1 was created rather easily. You just take a server. You've all seen this code. It's rather easy. But what it does is that it looks at a single TCP connection, and one request is handled within that TCP connection, which is rather inefficient. So one-to-one comparison, one TCP connection, one request. But what that leads to is that given a certain number of clients and a certain less number of endpoints, if two or more packets are getting sent to a single endpoint, we end up having one packet being blocked by another packet that's ahead of its queue. So this is called head-of-line blocking. And that's one of the downsides, aside from only having one request per TCP connection. This kind of is what's also led by that. So in 2015, an RFC was proposed to improve the traffic and being able to produce more performant applications with HTTP2. And what happens with HTTP2 is that instead of having a single request per a TCP connection, you're now able to have multiple, whereas instead of just a single request, it's a multiplex stream. So a single TCP connection can now handle multiple. And it goes up to quite a large number, and that depends obviously on the hardware you're running, and you're able to do 2 to the minus 31. I'm not good at the math, but you can do quite a bit. So one TCP connection and several streams. The HTTP2 server in Node is rather straightforward. You've got, you create a server, you have to provide key and certificates because it's a secure connection, and then you create a stream and respond with certain stuff. And then you get a bunch of stuff back. And you get an HTTP2. So it's rather easy. You can also have a compat mode that you still work with request and response like you're used to with HTTP1. Again, key cert, and then you just want to make sure you also allow HTTP1 and this end of the deal, so you can do a response.end like you would normally with a node, within regular HTTP1 node environment. All right, so kind of what's interesting for me about HTTP2 is that there's certain things that it brings to you that are quite different from HTTP1, and I call them little wins, and these are the things we'll go through a little bit more. And again, we kind of gave a brief summary about what HTTP2 is, but we'll do a bit more deep dive. So the three things that are kind of good for me or kind of interesting for me is being able to do stream prioritization, being able to do server push, and being able to compress HTTP headers. And kind of the wins we get from being able to compress HTTP headers is the less amount of traffic that we send over. So kind of these are the things we'll go over throughout the presentation, but we'll talk about how the connection actually happens. How does a server and a client negotiate? Because it's a little bit different than with an HTTP1. So you start off with a single connection, with single TCP connection. And a single TCP connection contains multiple streams, kind of like we talked about in the beginning. And those streams, they carry frames. So data is sent over in frames rather than your usual request-response situation. Everything comes in frames. Clients won't always know ahead of time if you're able to accept HTTP2. So you can send over an upgrade header, letting the other endpoint know that you can and would like to be able to handle this in HTTP2. And this is what it kind of looks like. All right. So the ALPN negotiations happen between the server and the client when you make a connection. And to be able to do that, this is kind of like a very agreement-based connection where both the server and the client have to agree on a bunch of stuff. And it goes on kind of like this. First, a client makes a call to the server and wants to be able to connect. It sends over a request or with a set of frames with an upgrade header. A server says that it can, in fact, upgrade and sends a 101. And after it sends a 901, the client will say that, yes, I acknowledge that I can upgrade. It kind of goes on forever. But after all of that, you're then able to send each other settings frames with things like stream prioritization information or the weights you want to give to certain streams and things like that. And we'll go over those in a little bit. So you send over settings frames. All right, so frames. Lots of frames. So we said that a single TCP connection is able to handle multiple streams, and a stream is frames, is data being put in frames. So essentially, a single stream will have things like data and headers, and being able to do a window update, aka increase the size of your stream. You can do continuation frames and things like that. So all the pieces of data are sent in these kind of little, small, tiny frames that you can have. And a bunch of these frames come with header blocks. So this is kind of when we want to talk about a little bit about how header compression happens. So compressing HTTP2 headers is part of my little list of HTTP2 wins. We said compressing headers is kind of one of the main points of being able to send less data over the wire. So actually, why would that be important? Well, that's important because with HTTP, with just any kind of header, you add about 500 to 800 bytes of overhead just to be able to transfer some information that you want the server or the client to know between the two endpoints. And sometimes it can be, in fact, kilobytes of just information being sent over. So compressing is a rather good way of being able to shrink the amount of information you send over. So that's a little bit too much. So what happens is that an endpoint will send over headers, and they're sent as a little bit of a list. And that list gets serialized in a header block. And then if you're familiar with Huffman encoded stuff, so that header block will be Huffman encoded into an octet block that could be then passed over to the other endpoint. And all of that all together gets sent over with a push promise frame or a continuation frame. So these two kind of endpoints send each other data. So endpoints communicate, those headers are getting sent. And another interesting thing is that HTTP2 likes to reuse the headers that it's already communicated from one endpoint to another. So that means that if you're sending a first initial header that was sent had a certain part of information, and the next one comes, you're only going to calculate the delta, so you don't send over several headers that have been already sent, so you don't send as much stuff over the wire. So not only is it compressed, it is also less headers are getting sent, and no repeat headers are getting sent over. So that concludes our kind of header compression. So there's also kind of this idea that you're able to build an HTTP2 client and an HTTP2 header server. So I want to kind of show you an example of what that would look like. So I've built out a server that simply does the things I showed you in the beginning, just a server that takes in a key and assert. I'm doing local development, so I'm using a package called TLS keygen to be able to help me generate those certs and keys. And then what I am doing is I'm just starting a stream and sending over stuff when the stream ends. But I also want to build up a client to be able to communicate with the server, so drawings come to life now. What the client will do is that instead of create secure server, what we're doing is we're connecting to localhost. And what we're sending over is just, we're just looking at the data that's going to be sent over. And I also wanted to see the headers on either side. All right, so I have a server already started, and then I should just go up. So then I just get the Hiya Vancouver that I sent over from the server, but I also get the headers that I've sent before, which are these. So all the data gets communicated with the headers, and it's rather easy to come up with a server and a client and to be able to make requests. I've also made an abstraction for this kind of request situation, and it's called HTTP2 request, and you can find that on my GitHub. It's a tiny, super hacker version of requests that works with HTTP2. That's called HTTP2 request. Very good naming. So we kind of talked about the fact that a single connection carries multiple streams. And we kind of want to look into what an actual stream is and what can you do with this stream information, how is it different. So a stream is independent bidirectional sequence of frames exchanged between a client and the server in an HTTP2 connection. I got that straight up from the RFC, but this was actually a good explanation. Everything else in the RFC was very confusing. This was good. The stream is part of a connection, and it kind of goes through, it's a little bit more stateful, so it goes through several states, and you can have it in several different states. It goes between closed, idle, reserved, open, half closed, so your data is communicated based on the state that a stream can be in. And we mentioned that multiple streams exist per single connection, and they're handled within a single connection. But data does not necessarily have to be sent in a single stream. What happens is that each endpoint can combine the frames it receives from multiple streams, so nothing has to be very sequential. And HTTP2 protocols will just figure out the most efficient way of being able to send that data and be able to combine it at the end, which is a nice thing. But what also comes with streams is being able to prioritize these streams and be able to tell your endpoints the things you want to be handled first, especially if you have more important data being sent over. And that's kind of what makes it data processing part of HTTP2 a little bit faster. Because you have many streams per connections, you might want to prioritize resource allocation based on the things you sent over. And what you do is you end up assigning dependencies to each stream you sent over, whether it is on the server or the client endpoints, and you can give them weights. And weights work sort of in a way where you have several streams that a client sends over, and you can give parts of your streams different weights. So if a stream 2 has a weight of 12, it will be prioritized over stream 3, which only has a weight of 6. So if your data in stream 2 is way more important, it will be handled faster than stream 3. You're also able to control the way data is handled with HTTP2 with something called flow control. Again, single connection, multiple streams. And because we're multiplexing these streams over a single connection, this can cause congestion in a TCP connection, and you want to be able to kind of control the flow of what your connection is like. So flow control will allow you, either of your endpoints, to communicate how much it can handle at a certain time. So your data and headers and window update frames, the window update frame will then communicate the fact that you are using a certain amount of resources in your particular communication setting. And once you're taking away data or taking away resources from that particular setting, you can't use it as much. So it works like a credit-based system. So let's say you have 100 points every time. You start off with 100 points, and then you send back some data and some headers, and that used up 5 of your points. You're now left with 95 points. So once you reach 0, you're kind of left with no data or data allocation left. So you kind of just communicate how much more load you can handle with window update and being able to control your flow like that. It also helps you prioritize streams so they don't block, and kind of using the weights and the flow control system, you're able to handle it a lot faster and a lot easier. So how does this actually work in Node.js? We'll do a little bit of a brief overview of how it happens in Node. So a client makes a connection, makes an incoming secure connection. Your server will handle that. What will happen is libuv will handle the I/O process of the connection and parse the information you get from there. You will then decrypt the connection with libSSL, and then you will open a stream in a session given that information. So this will be within your Node.js application. After that, you're ready to handle frames. And once that stream is open, that session is open, we go to the ng HTTP2 package, which will parse the request into frames. And those frames are then able to be handled within your Node.js application. And once those are handled within your Node.js application, you're able to send back a response and kind of handle it within your own layer. So then I wanted to kind of briefly talk about HTTP push, and that's kind of on the list of little wins that I've had. So we kind of know how a regular application handles data processing between 2 endpoints. You kind of get the things you need from the server, and all the time it's kind of goes back and forth, and then your protocol that handles the connection is just HTTP1. But what happens with HTTP2 is that you're able to preemptively push information to the client before it needs it. So it happens ahead of time, and what that does is that every time you make an initial request, the server can say that with that initial request, not only will you need the information you're asking for, I know ahead of time that you're also going to need some other things. And those other things are then put into the browser's cache. So we know the client is asking for HTML, but we'll also need CSS and maybe some images, and then we send those to browser cache. So when the browser decides that it actually needs that information, it doesn't have to make the whole round trip to the server and just gets it from its cache. All right, so I wanted to show you an example of that, and this one's like a very easy, very small thing that can be handled pretty much right away and implemented right away. All I'm sending is CSS over. So let's open up push. So what this code does is it creates a secure connection that, and then it also pushes the stream of bundle.css, which is what we're going to need. So every time the client is looking for bundle.css, it will know that the information has already been sent over, and it's in browser's cache. All I'm sending with the bundle.css is just coloring the background to be blue. But what I'm actually responding with is just a little bit of inline, very hacky HTML, just to be able to get something to work. And then if we were to head back to our browser and reload this, I'm obviously sending a little text that says butts. It's very good prototyping. But the very, very important thing is that I can see that everything was handled in the protocol called H2, which is what HTTP2 is, but also the fact that bundle.css was actually sent through HTTP2 push, which is different than what we've seen with this. So it's rather easy to be able to preemptively send stuff to your browser's cache. The nice thing about it is that things like CSS or little bundles of CSS that you might need for your specific pages. It could also be just actual JSON data. It could be images and things like that. So it's interesting to see what people might want to use this for. But I thought I'd give you like a nice, easy example that's easy to see. But what happens with HTTP1 is that when you send this over, it's just information that goes back and forth, and you have it under HTTP1 protocol. So what's happening with HTTP2 in the future, which is what I wanted to also share a little bit. There's a few different resources that you can kind of track information outside of the Node community. Obviously, for Node stuff, /Node on GitHub is probably where you would want to look. But there's some interesting RSCs coming through in HTTP data tracker kind of website. I can share my slides and the link for this. But the super interesting one is some work happening around WebSockets and HTTP2. It sounds like this might be an interesting way to be able to handle WebSockets with HTTP2 and kind of being able to work with that. There's also some work over in this GitHub repo that talks about other extensions that people are kind of proposing to be able to work with. An interesting one here is being able to work with cache digest. And that could be really cool to see implemented. So basically when I think my understanding of this was that if you're working, if your client is hitting a particular endpoint several times, you might not have to be able to kind of, it's HTTP2 on a larger scale, I think, is a better way of phrasing it. So the TLDR, things we talked about here. Single connection, multiple streams, which makes this a lot faster of a protocol. It's part of this fastness of the protocol comes from the fact that headers are compressed and are reused. We're able to work with flow control to prioritize the streams so they don't block the process you're working on. And you're able to preemptively send some data over to client's cache when you work with it. You can also work with compat mode, so you don't have to specifically work in HTTP2. And that looks like that. And thanks so much for listening. If you want to say hi, I'm on Twitter, or you can email me, that's also a way. Thank you.